So we've talked about describing the shape of a distribution. We've talked about looking at the number of humps, whether it's bimodal or unimodal or uniform. We've talked about describing the center of the data using either the mean or the median, depending on the context. Another thing we want to describe is how spread out the data is, okay? And we're going to go from like the crudest to the most detailed statistic you can use. So the range is sort of the crudest, right? Because all you're doing is you're taking the max value and subtracting the min value. So in our case up here, these are the test scores. If you just do your max minus your min, you're going to get 100 minus 45. Right, so that's a 55-point difference between the max and the min. That's the range. Now it's very crude because it's just two numbers in the calculation. It doesn't tell you a lot about how spread out the data is in between those numbers. So it's basically your sort of maybe the first thing you'd look at, but it's not necessarily the best measure of spread. We'll often use the interquartile range and what's called the standard deviation, which we'll get into in another video. Here we'll just calculate it on the calculator. So the interquartile range is just Q3 minus Q1, quartile 3 minus quartile 1, where Q1 is the median of the first half of the data, and Q3 is the median of the second half of the data. So we'll do this. I'm going to first do this on the calculator, and then in another slide we'll actually do it out by hand to make a box plot. But just return to your calculator. It should have these data values in there. I've already talked about in a previous video how to put the data values in there. So either re-put them in there or just go revisit that list. And so what you'll do again is, as we've done before, you've got all the data values in list 1 or whatever list you have. Hit stat, go over to calculate, one variable stats, hit second, and the number that corresponds with the list your data is stored in, and you get all these statistics. Now just scroll down and you'll notice that Q3 is, so again the interquartile range is Q3 minus Q1. Q3 ends up being, looks like 85.5. And Q1 is 72. And that, when you subtract that, you get 13.5. Okay, so that's how we find the interquartile range. Now while we're here, we're going to report the standard deviation. Actually, before I do that, let me write another statistic that measures the spread called the variance, just so you know where this term is. The variance is another key measure of spread, although the units are a little weird in it. So the variance in your calculator is the square of the standard deviation. So actually, so we'll come back to that. Let me do the standard deviation first. So in your calculator, the standard deviation is the value you get where you see that little s with an x. Okay, so in our case, our standard deviation is 12.195. Okay, now you'll also see another symbol there, which is that Greek symbol. It's a Greek S. And that gives a standard, that is another type of standard deviation. That's actually, that's really what the standard deviation is. The one above is what's called this standard error, but I'm just going to write, this is the sample deviation. Okay, and in statistics, generally, you gather a sample from a population, and then you calculate statistics on that sample. And so we're going to assume that this list of data is the sample. If that was everybody we cared about, that might be the whole population, and that in that case we might consider this the population standard deviation. Okay, so really most 99% of the time you're just going to be concerned with this one, okay, the standard deviation for the sample, or the sample deviation. Now all the variance is it's just the square of those numbers. So if you just take your standard deviation, your sample deviation, and you square it, you get 148.72. So that's the sample variance. And of course, if you square the population standard deviation, you get 142.52. And that's the population variance. So the variance it's interesting that the calculator will tell you the standard deviation, which is really the unit we're going to use most of the time. It turns out when you do it by hand, you encounter the variance first in the calculation, and then you get the standard deviation by square rooting. We're going to let the calculator do most of the work most of the time. However, the variance turns out to have some properties that are useful, so that's why it gets included as just a statistic that's worth noting. But in any case, at least for our purposes, you want to think of the three big measures of center: the range, again, the crudest, least informative, the interquartile range, and the standard deviation.